Hi guys, sorry I haven't posted a video in ages. I have had my exams and I'm going to make this a short video because I'm quite ill. So yeah, today we're going to do transport carbon dioxide and oxygen and how it gets into blood and all that. I hated this topic, but let's bish bash bosh through it. So we need to learn about the formation of hydrogen and carbonate ions. So carbon dioxide in blood plasma diffuses into the red blood cells. This then mixes with water to form weak carbonic acid. Oh, not weak carbonic. Yeah, it is weak carbonic acid. Oh my gosh. Okay. It forms weak carbonic acid there. And this is catalyzed by the enzyme carbonic anhydrase. The carbonic acid dissociates to release H plus ions and hydrogen carbonate ions. The hydrogen carbonate ions leave the cell through diffusion, and to maintain the pH, the Cl chloride ions move into the cell, as you can see is happening over here. And this stops the imbalance of pH in the cell. So then what happens is that oxyhemoglobin, it releases oxygen, so there's just hemoglobin around. But because there's a build-up of H plus ions, it can get too acidic for the cell, which could damage the cell. So what happens is the hemoglobin that's left after the oxygen has dissociated, it attaches to the it attaches to the H plus ions, which produces HB, so it will be like that. It makes a hemoglobinic acid. So yeah, so water plus carbon dioxide makes weak carbonic acid. This dissociates into H plus ions, HCO3 minus ions. HCO3 moves out the cell, Cl moves into the cell to maintain the pH, which is the chloride shift. The oxyhemoglobin dissociates with oxygen. Oxygen moves out the cell. Hemoglobin associates with the H plus ions and acts as a buffer so that the cell is not too acidic. Alright, so what I'm going to talk to you about next is the association between oxygen and hemoglobin. So I've conducted or written, or whatever you want to call it, a little love story for you. So there are the hemoglobin molecules, and one day 4 oxygen molecules are just trotting along. The hemoglobin molecules spot the oxygen molecules and instantly fall in love. However, because of their shape, the oxygen molecules can't get with the hemoglobin molecules. So eventually, more and more oxygen molecules start to fall in love with the hemoglobin. And there's a lot of oxygen trying to get into the hemoglobin. And eventually, after a long time of trying, one oxygen finally gets to the hemoglobin molecule. And this changes the tertiary structure of the hemoglobin molecules. This changes the arrangement of the hemoglobin molecules, which allow more oxygen molecules to enter and bind with more hemoglobin. And that's a true love story until until carbon dioxide comes. So I left off, the hemoglobin molecules were really happy with the oxygen molecules. They're really loving their life. They're really happy and in love. However, what does happen is that your body produces carbon dioxide as a waste product, and when this gets into your bloodstream, it makes the cell a bit more acidic, like I told you before, because it produces dilute carbonic acid. This then slightly changes the tertiary structure of the hemoglobin, and it means that the hemoglobin loses its affinity for the oxygen, and the oxygens leave. There you can see we've fallen out of affinity with you, and hemoglobin molecules are empty, and they go around looking for another oxygen molecule. And that's it. That is all of it. I'm not sure if I told you, but so this change in structure, the change of tertiary structure right here. Oh no, not this change of structure, sorry, never mind. The change of arrangement of the hemoglobin molecules is called a conformation. Oh, I can't fit that in there, can I? Right. Conformation. So this is a conformational change. And that's pretty much it. So, first of all, oxygen, it can't get in. It's really hard to get into the middle because of the structure of the hemoglobin. However, as the amount of oxygen molecules build up, they then, one oxygen molecule is able to associate with the hemoglobin molecule, which causes a conformational change, and then this means that more oxygen molecules can bind to the hemoglobin. However, eventually, when carbon dioxide is released, this creates weak carbonic acid, and this makes the cell more acidic, which changes the tertiary structure of the hemoglobin, which makes the oxygen lose its affinity for the hemoglobin, and it leaves and enters your tissue cells. So that was just a quick recap of what we did. Thank you so much for watching. I'll try and upload a bit more. To be honest, this is just for me, like next year, to see if I can revise off this. But yeah, hopefully it will be helpful. I'll be recapping everything. If you want me to post anything, if anyone wants me to post anything, just hit me up. I will try and get to that.